Hello, welcome to experiment number 6. In this experiment, we are going to be studying DC circuits, which involves only resistors, and we're going to connect these resistors in parallel and in series. So if you're sitting at a table that has this equipment, that will be for part A, DC electricity. This other part of the experiment, part B, involves other equipment, including a thermistor, which you will actually include in a bridge circuit that you're going to create. You're going to calibrate this bridge circuit, and then what you'll have is a digital thermometer, which you are going to use to determine the temperature of Greek coffee. This year it's Greek coffee, and it's over here. Okay, so let's begin with this part first. Beginning with this experiment, we are going to use an instrument called a multimeter. This multimeter allows you to measure 3 different electrical properties that we're going to need to measure for this experiment: voltage, current, and resistance. We have a pegboard here, which we will use to mount a switch, a DC battery, and 2 different resistors. Once we build our circuit, we are going to connect the components with these jump wires that have alligator clips at the end. And we are going to use a multimeter to measure, like I said, 3 quantities: the voltage that's applied across each resistor, the current passing through our series or parallel circuit, and confirm the resistances of these 2 resistors. So let me begin first by actually showing you how to set up a simple series circuit with 2 different resistors. And the very first circuit we are going to build is this one here. Now, this is an electrical schematic diagram, and in this electrical schematic diagram, there's different symbols. These zigzag symbols are going to be our 2 resistors, R1 and R2. This broken connection here is actually the symbol for a switch, and this symbol here is the symbol for our battery. Okay, so in order to make sure that we connect this electrical schematic diagram correctly with all these wires, it is always a good idea to lay out the components on the board in the same relative position as you see them in the electrical schematic diagram. So the switch, we'll place it at the lower left-hand corner. The battery, with the positive end to the left, we'll mount it to the lower right-hand corner of our pegboard, and R1 and R2, the 2 resistances, we're going to mount at the top. Now we are going to connect this circuit. So using these wires with alligator clips at the ends, we start off with our battery. We connect it to our first, well, it doesn't matter which resistor it is, but to R2 in the diagram. Then, from this end of the resistor, we connect it to the other resistor, R1. R1 continues on to the switch. So we have a wire that goes from R1 to the switch. And because this is a special switch, it's a single pole double throw switch. So if I close it like this, these 2 terminals are going to be connected. If I close it like this, there is no connections with anything. So I have to make sure I close it this way. Otherwise, if I have it like this, there will be a break, and the current doesn't connect here or here. Okay. So I attach this other wire, and now what we have here is It looks like a four-leaf clover pattern, but what we have here is our series circuit. So the series circuit in the diagram is very simple looking and very boxy looking. Over here, what we have looks more like a mess of spaghetti, but we have to be able to convince ourselves that what we have here is actually, in fact, the same circuit that we have here, okay, using real wires. Now, what they want us to do is use this multimeter initially as an ammeter to measure current, okay? And in the schematic diagram here, you'll notice that the ammeter is connected in two different places. Not at the same time, because we're only going to use one multimeter. So here, we are going to measure the current between the switch and R1. The switch and R1. So let's set up this multimeter to measure current first. Take your two wires. One wire is always connected to the common port. It says COM. And your other wire, if you're going to be using this multimeter to measure current, has to be connected to this port, which actually has the symbol MA on it for milliamps. Because we're going to be using a very low voltage and high resistances, the current will not be more than a few milliamps. So, but if we had much higher voltages and lower or lower resistances, we can use this port instead, which can measure up to 10 amps. But for this experiment, we connect it here. So we have now our multimeter connected to read current, and this rotary dial has to be set to the correct setting. You notice that there's two settings here. One of them is capital A with a squiggle, and the other one is a capital A with a straight line. That's a shorthand notation to tell you that this area you can measure AC current, and in this region here you can measure DC current. Because our voltage source is a DC voltage source, a battery, we are going to be measuring our current in this section, in this area here too. Does that make sense? Okay. Now, notice in the electrical schematic diagram, an ammeter is part of the circuit. Okay, it's part of the circuit. Since you want all the current to pass through the ammeter from the resistor to the switch, okay, you have to break the circuit to insert an ammeter to measure current. So what do you do here? Because ammeters are connected in series, you have to break the circuit and connect the ammeter to those 2 points. Now, when we turn it on, you will notice that there is no reading. Why isn't there any reading? Look carefully at our switch. Our switch is not closed. It's now closed if I move it over here. Okay. Notice that the current now can pass from this wire to this wire. Okay. Now, why is the current negative? The reason the current is negative is because we connected the ammeter the wrong way. Ammeters allow you to determine the direction of the current. And right now, the direction of the current through the ammeter is going in the wrong direction. So, in order to get always a positive current, you have to make sure that the common end of your ammeter is always connected to the negative end of your battery.